All right, guys, today I'm going to review with you a few really important points for your test on thermal energy and heat. So what I want you to do is pay attention to this, pause it, think over the things we're talking about, and really make sure you understand what the answers are that we talk about. So which is true? So we know that the energy we put in cannot be created or destroyed, but we know some of it can be lost as like heat and other things. So the energy input is always going to be less than the useful energy output. Okay, because when we put gasoline into a car, all that energy is not useful. Some is lost. Okay, now a power plant. Let's look at this. We have fuel to steam. So we have chemical energy being transferred into thermal energy. From 2 to 3, we have mechanical energy of this turbine spinning to electrical energy of the third one. And from the steam to the turbine, we have thermal to mechanical. Okay? All right, in order to change a solid to a liquid or a liquid to gas, water must absorb a large amount of energy. So water can absorb a large amount of energy while producing small changes because water has a very high specific heat. It takes a lot of energy to increase its temperature 1 degree. So which are we going to have best as a conductor? We know it needs to be a metal, and right here I automatically see a metal spoon. All right, Sasha and Eric want to go sledding. What can give them enough energy? They need the tallest hill. Yes, it matters that it's metal, but if they don't have a tall hill, they're not going to go anywhere. All right, all matter is made up of atoms and molecules. They're in constant motion and they collide. Think of colliding as hitting each other. Which of the following is typically transferred during these collisions? Well, gravity is not transferred. They don't throw protons around because that would change the element. So energy is what would be transferred. If a stone is dropped off a high cliff, which is going to be transferred? Well, maximum potential is going to change into maximum kinetic. Okay? So, be sure you understand that. Jill is getting ready to push Frank in the swing. She pulls him back as high as she can, potential. And the initial energy transfer that accelerates is potential energy being converted to kinetic. Melissa's going to bake brownies in an electric oven. She turns on the oven light. So we're talking about just the oven light. The oven light would be electrical to light. Okay, ceiling fans. We did this on your quiz. Ceiling fans need electrical to make it move into mechanical. All right, so in an engine of a car, some heat is released. The release of heat is less useful. It's wasted. So what happens to the majority of the heat? It's usually, think about your car. That heat that's under your engine is spread around. It's usually like convection. It may be steam when you open the top of your hood, or it may be conduction. It may be making the other parts hot, or radiation. You can stick your foot under your car and feel the heat. So energy is the ability to do work, and the primary energy transformation that occurs when a match is lit is going to be chemical into heat and light. And all right, this is the same thing we talked about first. This is our Sankey diagram. What we see is energy in is more useful than energy out. So the amount of useful energy that is produced is equal? No. This energy produced is not equal. The amount of useful energy that is produced is less than the energy that was initially added to it. And that is going to be it. All right. From point A to point B, he's sitting at the top of the hill. At point B, he's moving down the hill. At which point does he have most kinetic energy? Not at point A where he starts, but it's going to be greatest at point B. Okay? Greatest at point B. All right, what causes kinetic energy of atoms to increase? Well, not decreasing the speed, but heating it up, we know, can cause their speed to increase. All right, heat can be transferred by conduction when an object is in direct contact. Why? Because solids particles are more closely packed together, so they can transfer heat quickly. All right, let's look at the second part. We know that energy cannot be created or destroyed, so this is not true. Energy cannot be created or destroyed, but only change from one form to another. Okay, what do we call the things that reduce the flow of heat transfer? Those are going to be insulators. Energy from the sun travels as radiant energy. Okay, a device that converts thermal heat into mechanical. Okay, we know that it's not going to be a conductor. The only thing that has to do with heat is going to be this heat engine. Okay, where will convection most likely occur? We know it's not solids. It's got to be liquids and gases. It's circulation of liquids and gases. Kinetic energy of an object. increases as its velocity. You know, kinetic energy is moving energy, so its velocity will have to increase. So now we need to do specific heat. So remember, it's the triangle, right? And in your triangle, mass goes on the bottom, change in temperature, 200 minus 0 goes on the bottom, and specific heat goes on the bottom. So you're going to multiply 2250 times 0.129 times 200. Why? Because the change in temperature is 200. Okay? The amount of energy that it takes to raise 1 gram by 1 degree is your specific heat. Here's another one. We've got your specific heat. Now they give us the joules. Remember, joules goes on top. And they also give us the change in temperature. So we do Q, this is your Q, it's going to go on top, 150,000 divided by 800 divided by 15.5. All right, here we go, another one. Specific heat is 2.45. And our specific heat of object B is 0.82. So which one will heat up faster? Well, the lower specific heat is going to heat up faster. All right, what is the substance that absorbs, what is specific heat? Sorry, we're looking for C on the bottom. So it gives us 3,500 joules. That is going to go on top for your Q. Divided by 100 grams, your mass, divided by your change in temperature. 70 minus 20 is 30. I'm sorry, is 50. Sorry, so we do 3,500 divided by 100 divided by 50. Okay. Now, as temperature goes up, this is a review. From 25 to 60, you gotta look where your temperature is. The material is going to be heating up, absorbing heat, and the kinetic energy is going to be increasing. And right here, we see that something is happening here. This is what best explains the plateau. Well, the temperature is right here in the time on the bottom. The temperature is not increasing. The temperature is decreasing, but that doesn't explain the flat line. The energy remains constant. Well, we know energy is always changing. So the answer is that the energy of the system is going to be decreasing. That's why the time is sitting there. It's taking time to cool down. The energy of the system is decreasing. All right, that's your whole review for your test. Have a great day.